It is time for this week's sponsor interview now with Feross Aboukhadijeh, the founder of Socket. Socket is a software supply chain security company that can stop malicious packages getting into your software. And Feross and his colleagues have been playing around with LLMs lately, and the use case here actually sounds pretty reasonable. So here's Feross explaining how Socket is using LLMs to explain things to users, but also to automate some analysis of software packages and changes made to them and whatnot. That's interesting stuff. Here's Feross.
Yeah, so Socket, we scan and analyze all open source packages that are published to NPM, PyPy, and the Go ecosystem. So we're looking at all this open source code. It's too much for a human to analyze, right? Way too many packages. We look for signals in those packages that indicate the package could be malicious. And so just to be clear, malicious is different than vulnerable, right? So we're looking, obviously, a lot of the times when people think of open source security, dependency security, they're thinking of vulnerable packages. We obviously do that, but also where the LLMs are most useful actually is in looking for malicious intent, right? So when we find signals that indicate the package is malicious, we use LLMs in two ways. The first is where you really get it to explain in plain English to the developer, what is this code doing and why should they care? Right.
Well, you say plain English, but it could just as well be plain German or plain Japanese, right? Which is another nice thing about LLMs, but go on.
Yeah, fair point. We don't have that piece working quite yet, but one way to think of it is that you take this machine output, right? Think about the output from a lot of the tooling that we use every day, and it's not necessarily something that a developer that doesn't care about security that much is just trying to get their job done. They're just trying to ship a feature. It's something you can use to explain the alert and why they should care. And so that's how we've used it, right? When we find a package that's been compromised, we can explain literally there, in English to them what the problem is. So we can say it reads environment variables from this, from your environment, and it sends them to a random IP address. Like, okay, pretty clear that that's not a good thing.
Yeah, you just did a screen share before we started recording and showed me, well, there was one instance where it was some package that got published that, it takes a bunch of environment variables and throws them into a Telegram channel, right? And I'm guessing it's not LLM-based analysis that's triggering the alert, but being able to explain that in plain language to a developer is probably more useful than just triggering an alert where there's a bunch of strings in it, suspect strings in it and stuff for them to look at, right?
Yeah. It's also pretty good at indicating, like if we're not sure that something's malicious, but we still want to flag it because it doesn't have that many downloads and it looks sketchy. I'll give you an example, right? Obfuscated code is added to a package, right? Having the LLM explain why that's bad is really useful. So you'd be surprised actually, it can oftentimes de-obfuscate the code. And I'm definitely not trying to say this is a panacea and can catch, can deal with everything, but we find cases all the time where we've caught malware that's still live on NPM or PyPy. It's out there and developers could install it if they were so unlucky as to install that package at that moment. And we're catching it, and the alert will come out saying something like, this script is obfuscated, and it dynamically creates functions through string concatenation to collect the user's environment variables and send them to a remote server. That's an actual. I just read that off on my screen. That's an actual alert. So I'm surprised at the number of ways you can use these things. They're not going to solve all our problems, but they're definitely good at explaining things, and they're definitely yet another signal to use when trying to figure out if something is malicious.
Yeah. So one thing that I've been saying and banging on about quite a lot over the last few months is that I see this stuff as being primarily useful as a interface, as a way of connecting people to computers through language, right? And I think there's all sorts of productivity benefits that come from that. So certainly the main use case that you've mentioned fits into that, right? And just with Call Out, like explaining alerts, and now you're doing the same thing. You're basically explaining the alerts, have a look at this alert and tell the user why it's occurring. But it also seems like there is that actual analysis component as well. And like with what Grey Noise is doing with SIFT, it seems like there is actually some analysis going on with the LLMs. So I guess, I guess what I'm getting at is perhaps I was wrong in just saying that it was purely an interface thing, but it seems like they are distinct. They're distinct functions, aren't they? There's the interface function and the analysis function. Where does it fall over though? Like, because you would have played around with this quite a lot. Like, what hasn't it been able to do?
Yeah, so it definitely can't, deobfuscate like arbitrarily obfuscated packages. It definitely, sometimes it thinks things are malicious that are merely a bad code, right? Like you'll see a lot of just, to put it mildly, I guess, there's a lot, probably most open source packages you shouldn't use, right? Like there's just there's a lot of stuff out there that I would say maybe.
So it can't distinguish bad malicious from bad incompetent.
Yeah, and there's a lot of bad incompetent. There's a lot of packages out there where we'll find that there's a network call being made and the package has no business talking to the network, right? And so that's where the LLM can actually be helpful, right? If you prompt it correctly, you can get it to say, okay, given the purpose of this package, right? Like what could this network call be doing, right? What data is this file looking at? Where's the data going? And you can get it to sort of do a little bit of thinking there for you.
So I'm guessing you've rolled this out into the product. You've actually got people using it. Like, what's the feedback been like? Because, this is all new stuff. Like, are people telling you it's magic, or are they just like, it just becomes normal?
We're rolling it out. It's been rolled out for a while, and it's how we catch. We catch about several hundred packages per week that are malicious that are being published to all these different package managers.
But you're catching them. You're not catching them necessarily with the LLMs, are you? You're catching them with different signals and then just getting the LLM to explain it. How many? Well, that's the question. How many are you actually catching with LLM-based analysis? And are the false positives that you alluded to there making that tricky?
So since we rolled this out in, I think it was March, we've detected about 8,700 packages using LLMs that are malicious. Now, when we find something that's malicious, we report it and try to get it taken down from these registries to protect the community, and then block it for anyone who's a Socket customer, so that if their developers are unlucky enough to update or typo and install or whatever, however they end up pulling these packages in, they'll be protected. So people are benefiting from it already. We've seen cases where Dependabot will bump a package to fix a CVE, but then that new version actually has some protestware in it. We talked about protestware last time, where maintainers maliciously modify their packages, and so then the socket bot will come in on that pull request and say, hey, actually, don't update that, and so you'll have the war of the bots fighting each other on the pull requests. So yeah, I mean, we definitely, it's a core part of the product. It explains all the alerts that we send. The developer sees the explanation directly in the product. People like it, and then we do have a human in the loop to go and edit those if they're not quite exactly what we want to say and what we want to put forth. So there is that human element as well.
Well, again, I mean, that's the other thing that I've said a lot about LLMs, which is they're a productivity tool. And, this is a great example of that, where you still need someone to oversee it, but it can do stuff at scale, stuff like this. So, you've got obviously signals that you will pull out, like, shunting data off to Telegram bots. You don't need an LLM to tell you that that's shady, right? So what percentage, I mean, are you LLMing everything that you get a hit on and doing that LLM analysis, or is some of it just bypassing that step, or have you just built this now into your process where you've got some signals that surface it and say this is dodgy, then it gets kicked into the LLM to do a little bit of analysis and then checked by a human and then onwards?
Yeah, it's the second thing you said. So
right. Okay. Now I'm much clearer now. Yeah.
Yeah. If you put everything into the LLM, I mean, depending on which providers you're using, but if you do it in the naive way, that's a great way to bankrupt yourself and use all your Series A funding. Send it all to OpenAI.
Yeah. I mean, we heard similar things from Proofpoint, right? When they're looking to understand the intent of an email and whether or not it's BEC, like you obviously cannot throw every single email that Proofpoint gets into an LLM, or, I think that would consume Earth's entire energy supply, basically, to do that. So you need to do some filtering. And have you been able to, so you mentioned before that you can get false positives. Like, how do you tune them out of this process, right? Because at that point, you're kind of beholden to the model to get stuff right. Like, if it starts making mistakes, can you actually teach it and say, hey, you keep flagging these things and they're not malicious, can you please stop doing that? And it does. I mean, how does that work?
Yeah, so we do tweak the prompts over time, and that is actually a big open area, not just for us, but for the whole industry, is how do you modify your prompts and improve the performance of these in a measurable, systematic way, so you're not just tweaking things and then improving some areas and then making other areas worse. So you need to have very robust test suites, benchmark suites, and have a very rigorous process to do A/B testing across any potential change you want to make to the prompting and into the training.
Now, when we talk about generating code, as opposed to, and look, this might be a really dumb question, but if I want to commit a malicious package into some sort of public repo, can't I throw my code into an LLM and ask it to make it look not malicious to an LLM? And would that work?
I don't know about that particular case. Maybe we should give it a try. I mean, so that's why you don't want to go with just an LLM as your only layer. I mean, Socket works with a whole bunch of different analysis.
I mean, that's the whole point, isn't it? It would have to bypass all of that initial filtering as well.
Exactly. Yeah. So I mean, we look at stuff like who's the maintainer? Do they have a history? Right. Like, what is the behavior of the package? So even before you get to the LLM stuff, and you just look at what does the core product do? You catch a lot of that kind of stuff. So really concrete example is there was a package that hundreds of thousands of downloads used by a ton of people, and it had code added to it that would open up a protest kind of pop up on production on your front end, your website, and we see that it's calling window.open to do that pop-up that wasn't there before. That's sketchy behavior, and so we call that out, and that's that's detecting the capabilities of the package. So we consider capabilities everything from does it open a pop-up window to does it access the network, does it read your files, does it read your environment variables, does it create child processes?
You can't hide that because it's literally what it does. So you can't ask an LLM to hide that. It's not gonna be possible to hide it and still be able to do it.
Yeah. I mean, you can definitely hide it in certain ways, but not. I mean, at the end of the day, the code has to run. It has to do the thing.
All right, Feross Aboukhadijeh, thank you so much for joining me for that conversation all about LLMs and how you're using them. Good stuff.
Thanks so much, Pat.
That was Feross Aboukhadijeh there from this week's sponsor, Socket. Big thanks to them for that. And you can find Socket at socket.dev. And that is it for this week's show. I do hope you've enjoyed it. I'll be back soon with another edition of Risky Business. But until then, I've been Patrick Gray. Thanks for listening.